We should be able to get through this within about 10, 15 minutes, 20 tops. And then I'll have you guys be able to work stuff in class and just get it over with and be done with it. The idea here is that we've done midpoints. We've found what's the halfway point between something. Midpoints were when you had the segment, it was the point at which it cut it into two equal congruent segments. Caleb, pulse the computer. Guys, pulse the computer. So that's what those would do. Now, the thing that we're going to talk about here is what happens when you want to know from one point to the other. Let's say 3, -1, and 8, 6. We could find the midpoint of that rather easily. We find the average of the x's, we find the average of the y's. But what if we wanted to figure out how long of a segment that is, just given endpoints? That's where distance formula comes in. Now, I know that you guys have seen this before. I know you've worked with it before. And this is where it becomes oh so important that if you have, I'm just thinking about there. Your name's not on the cup, just on the board.
Oh yeah. The bottom marker.
I don't think it works.
You did that too, did you?
Yeah.
So this is where this calculator comes in so important because the distance formula uses square roots. And what we want to do is we're always going to keep answers in what are called simplified radical form. Those are the actual real, I don't want to say real, but the, what's the word? Definite, exact, thank you. That's the exact answer. I got it. I'm pretty sure I had it for you. So here's what happens. How many of you guys know, you don't have to worry about a graph right now, but I'm going to show you what this does. So after we put away our cell phone,
Jason.
I have one.
no, it's the other girl I'm staring at right now.
I think it's like I'm not using it.
You were. For example here, if I wanted to find the, kill me, kid. If I wanted to find the distance between these 2 points, and I have ordered pairs, our ordered pairs are at -3 and +1, and the other ordered pair is at 2 and 6. So what happens is that to find the true distance between something, what we do is we actually are creating a right triangle. Now, not always are we creating a right triangle when we're doing this when we just have coordinates, but this is exactly what this looks like. Because what we do is we find the horizontal distance and we find the vertical distance. And it makes a right triangle. And what's the formula that everybody remembers about right triangles?
So isn't it x1, no, x,
No,
x2?
No, you remember that. What do we know about right triangles? We know that the Pythagorean theorem is a squared plus b squared equals c squared. Well, this c squared then actually becomes the distance between 2 points. Well, what we need to do is figure out what is the horizontal change. What is this vertical change? So when I'm going left to right, what values are those in a graph? The x's or the y's?
X's.
The x's. So if this number starts at -3 and it goes to 2, how far apart are those?
What about
5. They're 5 apart. So the horizontal distance here is 5. If the vertical distance was between 1 and 6, how far apart is the vertical distance? 5. So that basically is telling me that I could take 5 squared plus 5 squared, and what do I get? 50. Now, 50 would equal the c squared, but that means you have to solve for c. So what button do you press on a calculator?
the square root?
Square root. So you would hit the square root of 50, And lo and behold, you get 5 root 2, which means the horizontal distance between those 2 points, or I'm sorry, not the horizontal, but the actual distance between these is 5 root 2. Well, you're not always going to be plotting things on a graph using the Pythagorean theorem, because in essence, that's all the distance formula is. What we have here is another way to write it out, and we write it out in terms of ordered pairs. Okay? So if I take our example here again, 3, 1, 2, and 6. Is it okay if I flip to a clean shape here? I'll wait. I'll wait. No reason to go too fast. It's always the kid in the front row. This seat especially, because there's only one of you that can make one of you notice too. It's too easy. All right. Can I go to a clean one real quick now?
Yeah.
Yeah.
All right.
No.
So-
No.
You'll be fine with it. -3, 1, and the other one was what, 2 and 6? Thank you. So what we're doing here is we're going to find that horizontal change in x values. Remember how we did that the other day? We took the second x value, subtracted the first. We do the same thing. So we take the second x value, subtract the first x value, and then according to the Pythagorean theorem, what would we do to it? We would square it. And then we would add to it the second y value, subtract the first y value, and then what would we do? We would square it. And then this would equal that diagonal distance squared. But yet, remember, how did we undo squaring? There's your distance. Math, exactly. That's the distance formula, guys. The distance formula is nothing but Pythagorean theorem on steroids. That's all it is. It's the exact same thing as the Pythagorean theorem. It's the same thing. Find out how far apart the x's are, how far apart the y's are, square them, add them together, take the square root, done. Whiskey.
Does that mean I need to take steroids to be able to solve them?
No, it doesn't necessarily mean to, but I don't believe that steroids help the brain.
They can give you heart attacks.
Maybe.
Yeah. OCL, that's so true. Yeah, they might not help you solve that problem, but they can give you a nice heart attack.
I don't think hard.
So again, watch what happens, guys. Just like we've done in the past, the easiest thing to do here is label. Label them as you read them going from left to right. It's the easiest way of doing things here. You fill in the blanks. 2 minus -3, quantity squared, plus 6 minus 1, quantity squared. Now, the first few times that you do these, after we keep our foot off the desk, thank you, is that I want you guys to take your time. Do not try to put this whole thing in your calculator. You're going to screw up. All right? Break it into small chunks. Put in your calculator 2 minus -3. You get 5. 6 minus 1. You get 5. Take the extra 2 seconds to rewrite it down. You get the square root of 25 plus the square root of 25, which is the square root of 50, which is 5 root 2. If your calculator does not simplify radicals, you have to remember how to do that, or you have to spend 15 bucks. I don't know if they're still on sale at Walmart or not, but I'm telling you guys, it's simplified radical form is the way that we do stuff from basically here on out. We rarely, if ever, will use a decimal when it comes to solving equations like this. Very sad.
This makes so much more sense to me.
Remember I showed you that yesterday? Didn't it work for you? Do 50 divided by x squared and go to your table again and take a look at how it works itself through. Okay. Does yours simplify on the Casio? Or give you this? Square root of 50 is what happens.
Should have worn my shirt.
Hey!
Cool.
Life is good. Do me a favor. On your calculator, take 2 divided by the square root of 3. I want to see if it does that also. 2 root 3 over 3? You don't need a calculator, my friend. Here's what work. All right? Not too shabby? I know you've seen this before, right?
Yes, last year. Makes more sense this year.
Good deal. Find the distance between A and B. 2, 5, -4, and 8. Use your distance formula. Okay? Use your distance formula. Label the points and see what happens. Bits. We got duct tape. It'll go like, oh yeah, that's the old version of it. Yeah, the old one doesn't do that. Yeah. No, this is like the 3 or 4 or 5-year-old version of the multi-year. Yeah, feel very formal. I'm sorry. It's all good. That's right. It's like the I think he was also in pocket TI.
Okay, so here's a question, something that's.
You should have to be on Brian, why would you put that problem?
This is a really good calculator, why don't they just say, hey, this is the calculator you need to answer it, but look at your algebra and geometry. I know, it's too much logic, right?
Stop it. You still remember my name? What do you want?
Oh, I forgot. Hey,
What's that? Do you think I've known it yet?
so what's the name?
Mr. J.
Mr. J. What's up?
You just responded to Mr. J.
You know Mr. J is?
I'm much more advanced.
Place like up street.
No, I'm not saying, I'm not talking down on you guys all that.
So,
You know what?
I'm not gonna say this.
what's that?
Murphy's meat locker is just always freezing.
I think it's actually warm in here. I'm sweating.
No, it's Murphy's meat locker.
Remember, ladies and gentlemen, the distance formula is something that you're going to have to memorize. So my suggestion, which is a really good suggestion, I hate to say, write it down. Write it down every time, like the next day or so, as we're going through these problems. Write down the distance formula. As you write it down, guess what happens?
It gets
You remember it. Go figure. Label out our stuff. And we see what happens. So we have -4 minus 2, quantity squared, plus 8 minus 5, quantity squared. So this is -4 minus 2, which is -6. -6 squared is then positive 36. Ladies and gentlemen, if you're going
Oh, yeah.
a negative times a negative, oh boy. So
This is
let's do this. When you guys are working with stuff that have negatives within the parentheses, no matter what calculator you have, always, always, always put parentheses, -4 minus 2, close the parentheses, and then square it. This way, it encapsulates the negative, and it will not screw up for you. Because a negative times a negative should always become positive. It is one of the quickest, most normal mistakes that students make from Algebra 1 all the way up and through AP Calc. People always forget that button happens. Last year when I taught pre-calc, you would be surprised the number of times students screw up that little step, okay? So you have a 36 and, what is this, 9?
Yes.
No.
So you have the square root of 49. Now, according to our calculators, if you type in the square root of 49, I'm guessing you got 3 root 5. That's exactly what you should get. Now, I only have one more example for you, and I want you guys to have it in front of you because sometimes you're given examples, or you're given problems that are given a graph. And when you're given graphs, that means your life is even easier. Because what do you have to do when you have a graph? No. Count. Count. You don't even need to do that. Count. Graphs. When you have them given to you, I'll get the spares at the end. Watch what happens when you have a graph in front of you.
Wait, so this is the quiz?
Yes, this is a quiz.
Well, I'm not prepared. Sorry.
The quiz, all right, let's go.
Yeah, I thought we never would have done this.
Ladies and gentlemen, I'm looking at number 12.
Number 12. All right.
I'm looking at number 12.
Got some extra copies.
I'll get it. Just throw it on the table. Now, when we have, remember when you're doing distance formula, excuse me, you're working with the horizontal change and your vertical change. So basically all you have to do is count how far over you have to go and count how far up you have to go. So this is real tough. Try and keep up. Ready?
Hold on. Almost there.
Ready?
Yeah.
1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7. So it is 7 across the side. What? You gonna help me sing this time? Ready?
No.
We're going up. Ready? Ready? 1 little. Come on, let's go. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7. It's 7. The horizontal is 7. The vertical is 7. What are my A's and B's then? 7 squared plus 7 squared. Take the square root, and what do you get? 49 plus 49. Take the square root of that, and you get?
7.
That was that easy?
Yes, sir.
Wow.
When you have things on graphs, ladies and gentlemen, could you find the ordered pairs and do the whole long format of the distance formula?
Yes.
Absolutely. But since you don't have them, isn't it easier to count? Think about what we did yesterday. Did we do any math? No, we counted. Bless you. All right. Look at 11. Same idea.
Negative 8.
We don't know the lyrics. All right. So remember, we're counting. We're counting distance. Will our distance ever be negative? Bless you. No. So we just count. 1 little, 2. Come on. No. 1 little, 2 little, 3 little spots, 4 little, 5.
6 little spots.
5 that way, and let's go the other way. Ready? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8. It's 5 by 8.
40.
Huh?
I mean.
Oh, I see where you're going with that, but remember, it's 5 squared plus 8 squared, and then we take the square root of it. Correct. So, square root of 89, if I press the square root of 89 to my calculator, what does it give me? Which means I'm done. That means that this cannot be simplified any further. What that means is that there are no perfect squares that go into, are factors of 89. You guys remember what perfect squares were? 1, 4, 9, 16, 25, 36, 49, 64, and so on and so on and so on. So that's your answer.
Still that easy.
Bless you. You're obviously allergic to distance formula. What? No!
Yeah.
That's a good.
Yeah, actually we should.
Distance. Is that a diagonal distance, horizontal distance, or a vertical distance?
Vertical distance.
So do you need to use the distance formula?
No, it's 0.
Count.
0.
1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10 total spots.
Oh wow.
Oh, that was
Was that like on the spot?
You know, I'm nothing but an entertainer at heart, but I happen to have a degree in math. So the answer is 10. Finish this. This is all. This is the work. You guys can get this all done right now. I don't see any reason why you can't finish this.
I've got a question for you, Mr. J.
What's that?
Oh yeah. So for number 13, would it be 5 7?
It's just 10. It's just 10. Because even if you do the, there is no, it's just a vertical distance, there's no horizontal, so it's 0 squared plus 10 squared. Then the square root of it. What's 0 squared? What's 10 squared? What's the square root of 100? Why do all that extra work? Give me 1 second, wait.
Tell Mr. J on this formula.
Did I get it right?